All right, welcome to The Explainer. Today we're diving into a massive cosmic what-if. What would actually happen if the biggest planet in our solar system just, poof, became a star?
Yeah, it's a wild thought, right? So let's really break this down. What would the universe look like if our gas giant neighbor, Jupiter, suddenly burst into flames?
Okay, so before we can even imagine Jupiter lighting up, we gotta ask, why isn't it a star already? And trust me, the answer is pretty cool.
So check this out. When you put them side by side, the craziest thing is their composition. Jupiter is literally made of the exact same stuff as the Sun, mostly hydrogen and helium. It's got all the right ingredients, But how it makes energy? Totally different story.
And that is exactly why you'll hear scientists call Jupiter a failed star. I love this analogy. It's like a car with a full tank of gas, but the engine is just way too tiny to ever start. It just doesn't have enough oomph, enough mass, to kickstart that nuclear fusion in its core.
So that begs the question, right? How much more mass are we talking about here? And the numbers, well, they are literally astronomical. No pun intended.
Okay, so just to give you some perspective, right now, Jupiter's mass is only about 1,000th of our Sun's. Sure, it's the biggest planet we've got, but next to a star, it's a total lightweight.
To actually cross that line, to go from just a big planet to a star, to get that fusion engine fired up, an object needs to have at least 8% of the Sun's mass. And that's just the bare minimum to become the smallest, dimmest kind of star out there, a red dwarf.
So here's the bottom line. For Jupiter to ignite, you'd need to somehow pile about 80 times more Jupiters on top of it. Just try to picture that. It's an absolutely mind-boggling amount of mass.
Okay, so let's suspend our disbelief for a second. Let's pretend the impossible happens. In a flash, Jupiter gets that 80 times mass upgrade. What happens next?
Well, first off, it's not going to be this brilliant second sun lighting up our sky. No, it would ignite into something we'll call Sol B, a pretty small, dim, reddish star. You'd be able to see it from Earth for sure, but it would be more of a faint glow than some dazzling twin to our sun.
And this is the real kicker. You'd think the extra heat and light would be the big problem, right? But it's not. The real, immediate, absolutely catastrophic danger is invisible. The sudden, massive increase in Jupiter's gravity.
Yeah, this new gravitational monster would instantly start a cosmic tug-of-war. And guess who's caught right in the middle? Earth, and every other planet in our solar system.
You see, right now, our solar system's center of mass, the barycenter, is super close to the Sun. Because, well, the Sun is huge, it's dominant. But if Jupiter suddenly became a star, that balance point would get yanked way out into space. The Sun and our new Sol B would start orbiting each other, and that would throw everything into complete chaos.
And that would kick off a crazy domino effect. First, the barycenter shifts. That makes Earth's nice, stable orbit go totally haywire. Then come the insane temperature swings. We're talking boiling hot to frozen solid. And that leads, inevitably, to a pretty unthinkable endgame.
In this new, chaotic dance, Earth would basically have two horrifying options. One, get yeeted out of the solar system completely, becoming a frozen, rogue planet wandering in the dark. Or two, get sent on a collision course with the Sun, our new star Sol B, or another planet. Yeah, there's really no good outcome there.
And believe me, the chaos wouldn't just be our problem. The entire solar system would be violently redesigned.
That asteroid belt that Jupiter's gravity so nicely keeps in line, it'd be unleashed, sending a firestorm of impacts our way. Saturn, Uranus, Neptune, they could get kicked out of the system for good, and Jupiter's own moons would just be scorched into lifeless rocks.
And as if all that gravitational chaos wasn't bad enough, Earth would also get blasted by a ton of radiation. See, young red dwarfs like our Sol B are super active. They spit out these powerful, frequent flares of high-energy particles, which would threaten to literally strip our atmosphere away over time.
Okay, so after that pretty bleak tour of cosmic annihilation, what's the big takeaway here? What's the point of this crazy thought experiment? Well, the good news, the really good news, is that this can't actually happen. Phew. Stars take millions of years to form, slowly gathering up gas and dust. A planet can't just magically gain 80 times its own mass in an instant, so we can all take a deep breath.
But the reason this thought experiment is so powerful is because it shows us something incredible.
By imagining all this chaos, we get to see just how unbelievably delicate and precious the stability of our solar system really is. The whole thing works because of this perfect cosmic balancing act that we pretty much take for granted every single day.
You know, our nice, stable orbit is just one little piece of this amazing cosmic puzzle. It really makes you stop and wonder, doesn't it? What other perfect conditions had to line up, completely against the odds, just for us to be here at all?